Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on August 28, 2025, just yesterday. The standout result is a distributed system that speeds up experience collection by 14.6 times and, using that boost, lifts a QN332B agent on GAIA from 21.59% to 32.23% with 16.33% on the hardest level. The paper is titled AWorld, Orchestrating the Training Recipe for Agentic AI, and the implications for model training are quite significant. Beyond raw gains, the system makes large-scale rollouts practical, enabling reinforcement learning that closes the loop from interaction to measurable improvement. Also, the authors shared a GitHub repo. You will find a full framework for building and training multi-agent systems with Python packages, quick start scripts, examples, memory and tracing modules, MCP tool integrations, distributed training hooks, web and API launch commands, plus GAIA benchmark configs and docs. Alright, the intro just set the stakes with large speedups and accuracy gains. Figure 1 illustrates both outcomes. The left bars compare GAIA scores, where QN332B AWorld rises to roughly 32% and closes in on frontier systems, which signals meaningful capability gains. The right timeline chart contrasts rollout versus training time, showing a 14.6 times faster rollout under the distributed executor, so interaction becomes the dominant lever. The pairing highlights why throughput matters. Faster rollouts unlock better reinforcement learning. Okay, Figure 2 lays out the full pipeline. The top row shows the forward pass that constructs agents, defines communication protocols, and manages runtime state so tasks flow into high concurrency rollouts. The middle hardware band routes everything through a unified message bus to a distributed cluster that interacts with diverse environments. The bottom row presents the backward pass, where trajectories land in an experience buffer, trigger construction optimization, and feed agent training with standard reinforcement learning frameworks. The closed loop matters because faster, parallel interaction continuously supplies better data for improvement. Well, the pipeline overview just showed how messages flow through a distributed runtime. Table 1 now lists the built-in tools that make those interactions practical, because the agent can call specialized services rather than improvise everything in text. The catalog spans code execution and terminal control, a lightweight Excel engine, a calculator, browser automation, audio and image services, and a Google search interface. This toolkit broadens action space and reduces friction during long horizon tasks. So, the tool catalog just grounded how agents act in rich environments. Table 2 quantifies why distributed rollouts matter, because the runtime shrinks interaction time dramatically. The AWorld executor finishes rollouts in 525 seconds and the full cycle in 669 seconds, while the sequential executor takes 7,695 seconds for rollouts and 7,839 seconds total. The constant 144-second training time makes the contrast stark. Interaction dominates the loop, and parallelizing it unlocks the 14.6 times speedup. Alright, 2 takeaways stand out. Distributed rollouts shift the bottleneck, delivering a 14.6 times speedup that makes reinforcement learning practical, and that throughput translates into real gains, lifting QN332B on GAIA to 32.23% with strong hard-tier results. The broader implication is clear. Scalable interaction is the lever for agentic improvement. That is it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.